Welcome back, everyone, to another deep dive. Every day we use apps and websites that seem to just work, but behind the scenes,
It's all powered by complex software architectures handling millions of users without
crashing. Exactly, we're talking.
massive scale systems.
Like think e-commerce giants, streaming services, the works.
And it's fascinating how much this field has evolved, right? We started with monolithic systems, kind of.
Like a one-stop shop for your code, right?
Yeah.
Easy to set up, but
Notorious for scaling issues.
then we had the rise of microservices, which are like,
Specialized teams each handling a specific task, very flexible, but
can be a real headache to manage all those moving parts.
it really is. So today we're focusing on what might be called the Goldilocks solution.
Ooh, I like that.
That's Selective Service-Oriented Architecture, or SSOA for short.
Catchy.
And, of course, its front-end counterpart, SFA.
Our guide for this deep dive is Roshan Gavandi's book.
You got it. It's called Selective Service-Oriented Architecture, SSOA, and Selective Frontend Architecture, SFA.
And he really knows his stuff. Roshan's led some major system transformations.
He has.
And this book is a great resource for, well, really anyone in tech who's building systems meant for massive scale.
Architects, developers, anyone who wants to learn.
Now, what's interesting about SSOA is it doesn't ditch the monolithic core completely, does it?
No, it doesn't. It starts with that core, but...
It makes it modular.
Exactly. It's kind of like
A well-organized house where each room has a specific
purpose, but they're all connected by a...
solid structure.
Yeah. Now, the selective part is where things get interesting. With SSOA, you pinpoint the most demanding parts of your application, let's say.
Like the checkout process during a big sale, Black Friday or something.
Perfect example. And you extract only those parts into...
Microservices. Got it.
Right. Instead of scaling the entire website, you give the checkout process its own turbo boost.
Love that analogy. Avoids that elephant in the Mini Cooper problem we've talked about with monoliths.
Exactly. And to make sure those microservices play nice with the rest of the system, we've got the
Service composition layer. It's like
universal translate.
helping all the different parts of the system talk to each other.
That's a good way to put it.
I try. So we've got the back end covered, but what about the front end? What users actually see and interact with?
That's where SFA comes in, mirroring the SSOA approach.
Well, for the user interface. So instead of...
Yeah. Monolithic front ends can be a real pain to update. And
scaling them.
No.
Forget it.
Exactly.
So SFA, it addresses this by extracting specific parts into micro front ends.
Right.
So if you need to tweak something, you're not updating the entire website, just
the part that needs it.
smart. Give me an example, something relatable for our listeners.
Imagine the video player on a streaming platform. By extracting it as a micro front end, you can optimize it.
So even when millions of people are watching at the same time.
Yeah, even during the big game or a season finale, it still runs
Smoothly. No buffering nightmares.
Exactly.
Okay, so this all sounds great in theory, but how do we actually put these architectures into practice?
Well, the good news is you don't have to tear down your entire system and start over.
Phew. That's a relief.
Roshan really emphasizes an incremental approach in his book. It starts with
Assessing your current system, finding the bottlenecks, and then...
figuring out which parts would benefit from extraction.
So it's more like...
strategic upgrades rather than
a total system overhaul.
Yeah, and then you modularize the monolith,
Create those well-defined rooms.
Exactly. And that sets the stage for extracting those high-demand elements into microservices or...
micro front ends.
Depending on whether you're working...
back end or the front end. Of course, then comes the crucial step of...
building that service composition layer.
Or, as I like to call it, the air traffic control.
To make sure everything communicates as it should.
And finally, you deploy...
monitor.
And optimize that system, making sure it runs like a well-oiled machine.
Yeah.
But with all these distributed parts, doesn't security and compliance become even more critical?
It absolutely does. Roshan highlights a bunch of key challenges, like
securing the communication between all those microservices.
Making sure only authorized users and services can access certain parts of the system.
API security.
And then there's compliance with industry regulations like
GDPR, APA, all those acronyms.
Depending on the industry, of course.
Sounds like a lot to manage.
It is, but thankfully there are tools and techniques designed to address these challenges, like mutual TLS, for example. It adds an extra layer of security.
By verifying the identities of both the client and the server.
Right, before they can even talk to each other.
Like a double-check system. Clever. And it's very effective.
So we've got this secure, distributed system up and running. Now we need to keep a close eye on it, right?
Absolutely. Monitoring and observability are essential.
It's like having a
Dashboard for your entire system,
Sure.
tracking everything.
response times, errors, resource usage, you name it.
Exactly. And with tools like Prometheus and Grafana,
You can even set up alerts so you're notified if
anything starts to go wrong.
Yeah.
You're not just waiting for something to break. You're proactively looking for potential problems before they become major headaches.
Right.
Smart. But let's move beyond theory for a second and see SSOA and SFA in action. Roshan includes some great case studies in his book, right, showing how companies are actually using these architectures.
He does. Real-world examples from e-commerce, finance, healthcare.
Perfect. Let's dive into those case studies and see how SFA and SFA have tackled some real-world problems.
Sounds good to me.
All right, so we've seen how SOA can help us tackle the back end. We've touched on SFA for the front end.
Right.
What are some other advanced techniques we can use with SFA, to really optimize that user experience?
Well, one of the most effective techniques is lazy loading.
Lazy loading. Okay, tell me more.
It's all about efficiency. Instead of loading every single element on a web page at once,
Which can
or
take...
ever.
You prioritize loading what the user needs to see first.
Exactly. So let's say you're scrolling through a news website. With lazy loading, you'd only see the first few articles initially.
And then as you scroll down,
The rest of the articles would load in as you go.
makes sense. So it's all about making that initial page load as fast as possible.
That's the key, especially for complex web applications with a ton of content.
Because nobody wants to wait around for a page to load.
No, they don't.
Okay.
Especially for e-commerce sites, every second counts.
Makes sense. It's like, I don't know, walking into a well-organized store where everything has its place.
Versus one where everything's just piled up randomly.
You know exactly where to find what you need. Okay, what else can we do to make that front-end experience as smooth as possible?
Well, another really powerful technique is server-side rendering, or SSR for short.
Okay, SSR. That sounds a bit more technical.
It is a bit more under the hood, yeah. But the basic idea is this. The initial rendering of the web page happens on the server.
Instead of in the user's browser.
Exactly. So the user sees a pre-rendered version almost instantly.
Like it's already there waiting for them.
Right. And this is great for a few reasons. First, it can really boost your SEO.
Search engine optimization. Because search engines can...
Easily crawl and index the content.
Gotcha. So it helps your website rank higher in search results.
Yeah, it can. And it's also great for users who have slower internet connections or older devices.
Because they don't have to wait as long for that page to load.
Exactly.
So with lazy loading and SSR, it's really all about making that user experience.
As smooth as possible, yeah.
And these advanced patterns, they really seem to build on those core principles of SSOA and SFA that we talked about.
They do.
Breaking things down, optimizing for performance, it all ties together.
It really does. And speaking of optimization, we can't forget about the importance of DevOps and CI/CD pipelines.
Right, we touched on that briefly earlier. DevOps is all about...
breaking down those silos between development and operations teams.
It's about collaboration,
Automation.
communication.
All of that, yeah.
And CI/CD, that's continuous integration and continuous deployment. That's a big part of it.
It is. Imagine a pipeline where your code changes are automatically built, tested, and deployed.
Every time you make a change.
Potentially, yeah. It really depends on how you set it up.
So you're constantly integrating new code and then deploying it to the live website.
Yeah.
And you're doing it all automatically.
Yeah.
No more manual processes.
No more of that. And this is especially crucial for systems built with SSOA and SFA, where you might have multiple microservices or micro front ends that are all being updated independently.
Makes sense. Automation helps keep things organized.
And efficient, yeah.
And it minimizes those human errors that can creep in.
It definitely does. It's like having an army of tireless robots handling those tedious tasks.
Freeing up the developers to focus on the creative stuff.
Exactly.
But even with the best automation in place, things can still go wrong, right?
Of course, things happen. That's why disaster recovery and high availability are so crucial.
So disaster recovery, that's like if something catastrophic happens, like a data center outage.
Or a cyber attack. You need a plan to recover.
It's like an insurance policy for your system.
You got it. High availability, on the other hand, that's more about preventing downtime in the first place.
Keeping things running smoothly no matter what.
Right. Building redundancy into the system. For SSOA, that might mean
Data backups.
replication, yeah.
Failover mechanisms, things like that.
And using immutable infrastructure.
So you can rebuild systems quickly if you need to.
Exactly. And for SFA, we might use CDNs.
Content delivery networks.
To host those front-end assets in multiple locations so they're always accessible.
No matter what happens.
Right. High availability for SSOA often involves things like load balancing.
So if one server goes down, the traffic is automatically routed to another one.
And health checks to constantly monitor the system
It's like having a self-healing system.
that can identify and fix problems before they even impact the users.
I love that idea. But
Yeah.
we've talked a lot about building and scaling these complex systems, and all of this can get pretty expensive, right?
It can, yeah. That's why cost optimization is a crucial consideration.
Because no one wants to see their cloud bill explode.
Definitely not.
So how do we keep those costs in check without compromising performance?
Well, one key approach is right-sizing your resources.
Right sizing. Okay. What does that mean?
It's about choosing the appropriate computing power for your microservices. You don't want to overspend on resources that you don't need.
But you also don't want to under-provision and end up with bottlenecks.
Exactly. It's about finding that balance.
That sweet spot.
Right. Another powerful technique is auto-scaling.
Which means that your system...
Automatically scales up or down based on demand.
So if traffic suddenly spikes, you have more resources available.
And then when things calm down, the system scales back down.
So you're only paying for what you actually use.
Exactly. And for certain types of tasks, serverless functions can be incredibly cost-effective.
Serverless, we talked about that earlier.
Yeah, remember, you only pay when the code is actually executing.
Okay, so we've got some strategies for the back end. What about cost optimization for the front end?
Well, we can optimize our CDN usage.
By setting long cache lifetimes for those static assets.
Like images, JavaScript files, things like that.
So they're not constantly being downloaded.
Exactly. And we can also minimize the size of those assets.
To reduce the amount of data that needs to be transferred.
Right. And server-side rendering with caching.
So the server doesn't have to regenerate the same page over and over again.
Exactly.
Smart. Okay, so it sounds like there are lots of ways to keep those cloud costs under control.
There are. And it's an ongoing effort.
It's something you have to be mindful of throughout the entire development process.
Definitely. But a lot of organizations are still working with legacy systems,
Those large monolithic applications that have been around for years.
And transitioning those systems to a more modern architecture can be incredibly daunting.
Like trying to renovate a 100-year-old house.
It can feel that way, yeah.
Where do you even begin?
Well, Roshan provides some good guidance in his book.
Well, good.
He emphasizes that it's not about ripping everything out and starting from scratch.
That would be a nightmare.
It would be, yeah. It's about taking a more gradual approach.
So you're strategically replacing parts of the legacy system with those SSOA and SFA components.
Exactly. He calls it the strangler pattern.
Strangler pattern, okay.
Where you gradually strangle the old system by replacing parts of it with the new.
Until
the new system takes over completely.
So you're modernizing the system without disrupting those ongoing operations.
Right. And he also highlights the importance of identifying what are called bounded contexts.
Bounded contexts, what are those?
They're essentially logical areas of functionality within the system that can be isolated.
So you're finding those parts that can be decoupled without causing a chain reaction.
Exactly. And this applies to both the back end and the front end. You can use SFA to gradually replace parts of the front end with those micro front ends.
Starting with those components that need frequent updates or independent scaling.
Right.
It's a multi-pronged approach.
It is, but even when you've successfully implemented SSOA and SFA,
When you've modernized your systems.
scaling those distributed architectures can bring its own set of challenges.
Okay, like what kinds of challenges are we talking about?
Well, as your system grows, you're handling more users, more features, more data.
Things get more complex.
They do. And performance bottlenecks can emerge.
Where a specific service or component gets overloaded.
And that can slow down the entire system. It's like a traffic jam in your software.
Not good.
No. And another challenge is maintaining data consistency across a distributed system.
That sounds tricky. When you have data spread across multiple services,
Each with its own database.
keeping everything in sync can be a real headache.
It can, yeah. It's like trying to manage multiple to-do lists, each on a different device.
You need a way to make sure they're all up to date.
Exactly. And as your system expands geographically,
You have users all over the world.
managing latency becomes critical.
Latency, that's the delay
The
between...
user's action and the system's response.
Okay, so you want to make sure that users everywhere have a smooth and responsive experience.
Right. And of course, as the system grows,
Security risks increase.
they do. Safeguarding a large number of microservices or micro front ends requires a really comprehensive strategy.
It's like securing a city with multiple entry points.
You need a system that can protect all of them.
Okay, so we've got all these challenges. What are some strategies for addressing them?
Well, Roshan emphasizes the importance of using monitoring tools to identify those performance bottlenecks.
So you can address them before they become a major problem.
Exactly. And for data consistency, patterns like Saga orchestration can be very effective.
Saga orchestration, that's for managing those.
Complex distributed transactions.
Right. And for latency issues,
Deploying services and data closer to the users?
it'd make a big difference.
It can. And for security, centralized security policies are key.
Along with tools like IAM.
Identity and access management
Right. And regular security audits.
can help identify and address vulnerabilities.
So it's all about being proactive.
And having a multi-layered approach to security.
Okay, what about strategies specific to scaling those microservices?
Well, horizontal scaling and auto-scaling are key techniques.
So you can automatically create more instances of a microservice as needed.
Exactly. If traffic increases, the system can adapt.
And for massive data sets.
Data partitioning and sharding can be very effective.
So you're breaking those large data sets into smaller chunks.
And distributing them across multiple nodes or regions.
Okay, and as the number of microservices grows.
Using a service mesh can really help.
It's a service mesh, okay. What does that do?
It helps manage the communication between those microservices
And the traffic flow.
and security.
So it's like a traffic cop for your microservices.
That's a good analogy.
What about scaling those micro frontends in SFA?
Well, CDNs are essential for that.
They allow you to cache those front-end assets.
All over the world.
So no matter where the user is, they can access the application quickly.
Exactly. And versioning those micro frontends is crucial.
To make sure everyone's getting the right version.
And module federation
Which allows for that dynamic composition and updating.
can make the front end much more agile.
So it's not just about scaling those services and front ends. You also need to think about
Data and infrastructure.
so using distributed databases,
Data replication strategies.
global load balancing, things like that,
All of that's important.
to create a truly global system that can handle anything.
Exactly.
So we've talked about the present, we've talked about the challenges. Now let's talk about the future.
The future of software architecture.
What trends are on the horizon? What does the future hold for SSOA and SFA?
Well, there are a lot of exciting developments happening. Yeah, there are a lot of really interesting trends emerging. One that's already making a big impact is serverless computing.
Serverless, we touched on that a bit earlier with those serverless functions.
Right, but serverless is becoming much more than that. It's really a game changer.
In what way?
It allows developers to just focus on writing code without having to worry about managing those servers.
So no more setting up servers, configuring them, keeping them up to date.
Exactly. The code just runs in response to certain events, and
You only pay for the actual execution time.
right, so it's
Ugh.
incredibly efficient, and it scales automatically, so
You don't have to worry about capacity planning or anything like that.
right, the infrastructure just takes care of itself.
I can see how that would be really appealing for microservices in SSOA architecture.
Absolutely, it's a perfect fit, and it's even starting to influence the front end with the emergence of
Serverless front ends? Okay, now that's interesting.
it's still early days, but we're seeing some really interesting developments.
So what other trends are on your radar?
Well, artificial intelligence, or AI, is obviously a big one. It's transforming just about everything.
Including software architecture, I imagine.
Absolutely. We're starting to see AI-powered microservices that can make intelligent decisions.
Based on the data they're processing?
Exactly. They can analyze data, make predictions, even learn and adapt over time.
So it's like those microservices are becoming intelligent agents.
In a way, yes. And AI is also being used to assist with software development itself.
So tools that can analyze code, optimize performance, maybe even help design architectures.
It's all happening. Some people even talk about AI becoming the architect of the future.
Wow, so AI is going to replace software architects.
I don't think we're there yet, but AI is certainly going to play a much bigger role in software development going forward.
It's both exciting and a little bit unsettling.
It is. But AI isn't the only disruptive force out there. Edge computing and the Internet of Things are also having a huge impact on software architecture.
Edge computing, right? That's where you're moving processing power closer to where the data is being generated.
Exactly. Instead of relying on those centralized cloud data centers, you're processing data at the edge.
Which could be a user's device, a sensor, a smart appliance.
Anything that's generating data.
Okay, so how does that impact SSOA and SFA?
Well, with SSOA, you can deploy those microservices closer to the users, improving performance and responsiveness.
Because the data doesn't have to travel as far.
Exactly. And with SFA, you can run those front-end components at the edge.
making those web applications incredibly fast and snappy.
Right, no matter where the user is located.
It's like edge computing is bringing the cloud closer to us.
It is in a way, yeah.
Hmm.
And then there's the rise of multi-cloud and hybrid cloud architectures,
Which means that organizations are using
a combination of different cloud providers.
or a mix of public and private cloud environments.
Right, it's all about flexibility and avoiding vendor lock-in.
And this has implications for SSOA and SFA.
It does. With SSOA, you can deploy those microservices across different cloud environments.
So you're not tied to a single provider.
Exactly. And with SFA, you can host those front-end components wherever it makes the most sense.
Whether it's in the cloud, on-premises, or at the edge.
Right. And that brings us to another interesting trend. Blockchain.
Blockchain, that's the technology behind cryptocurrencies.
It is, but it's much more than that. It's a distributed ledger technology that can be used for all sorts of things.
Like what?
Well, one of the key benefits is that it offers secure, tamper-proof transaction processing.
So it's like a permanent, unchangeable record of every transaction.
Exactly. And this can be incredibly valuable in a distributed environment like SSOA.
Where you have multiple services interacting with each other.
Right. You can use blockchain to build decentralized microservices that handle transactions with a high level of security and trust.
Interesting. And what about SFA? Can you use blockchain on the front end?
You can, especially for applications that require strong data privacy, like healthcare or voting systems.
Makes sense. So with all these emerging technologies, it sounds like the future of software architecture is going to be pretty wild.
It is. It's an exciting time to be in this field. But one thing's for sure, SSOA and SFA are going to have to adapt to stay relevant.
In what ways do you see them evolving?
Well, with SSOA, I think we're going to see a rise in event-driven architectures.
Where microservices are triggered by real-time events.
Exactly. And event sourcing, which we talked about earlier, is going to become even more important.
For tracking those events and maintaining data consistency.
Right. And with SFA, I think we're going to see a move towards more composable front ends.
Composable, meaning that you can assemble them.
From smaller, reusable components.
So it's like having a set of building blocks that you can use to create different user experiences.
Exactly. And AI is going to play a bigger role in both SSOA and SFA, enabling more intelligent architecture design.
And self-healing systems that can identify and fix problems on their own.
Right. We're moving towards more autonomous systems.
It's incredible to think about what the future holds.
It is. It's going to be an interesting ride.
Well, on that note, I want to thank you for joining me on this deep dive into the world of SSOA and SFA.
It's been a pleasure.
We've explored the key principles, looked at some real-world examples, delved into advanced design patterns, and even taken a glimpse into the future.
It's been a comprehensive journey.
It has. To our listeners, we encourage you to explore this topic further. Roshan Gavandi's book is an excellent resource.
It really is. It's packed with insights and practical guidance.
And as we wrap up, we leave you with this thought. As software continues to shape our world, what role will you play in building the systems of the future? Until next time, keep exploring, keep learning, and keep building. Please let me know if you need any further assistance.